Good morning, class. Last time we were discussing about geotechnical engineering, and today we will be continuing the same subject, but further the compaction of the sand we were discussing, and we also discussed about the compaction curves. So today let us move forward and see what will be the effect of compaction on different parameters of the soil. Okay. So today we will be going through the changes due to compaction, as I just told you. Okay, and some numerical problems also we will be solving. So let us see one by one. First of all, if you remember, we had already discussed that what is compaction and what is the compaction curve, something like this. Okay, and there was a curve like this as well. So this is actually a compaction curve, and here it is the water content, and here we will be having the gamma d or dry density. Okay. So in different moisture contents we will be having different gamma d values, and this part, this the highest one, highest gamma d was called as MDD, which was the maximum dry density. Okay. And corresponding to this maximum value of dry density, we had a water content which was named as OMC or optimum moisture content, or OWC, optimum water content. Okay. So this we have already discussed in our last class. What was this line? This line was actually the zero air void line. Okay. So this was the case which we had already discussed. Now let us see further into this. To facilitate easy compaction, some amount of water is added to the soil, and water content at which maximum dry density of the soil can be obtained is known as optimum moisture content. As I have already told you, if the soil is in dry state, okay, if the soil is in dry state, what will happen? There will be no good compaction, or the compaction will be hindered, because the particles of the soil will be in the flocculated form. So due to that, it will resist the compaction process. But as we increase the water content to a level, then what will happen? They will get dispersed, and due to this dispersion we will be able to compact them to a greater extent. Okay. But remember, it is not always the case. Up to a certain level only the MDD will be obtained, or this will increase. After that, you can see it is going to decrease slowly. Okay. So here we are just discussing that if the water is added to the soil to a limited amount, then we will be getting the maximum dry density. Okay, and corresponding it is called OMC, or optimum moisture content. Now if the water content added is less than the OMC, then it is called dry of optimum compaction, and if the water content is more than OMC, then what will be it called? Wet of optimum. Okay. What does this mean? If this is your OMC, this line is your OMC, here this area and this area, these are divided into two parts. This will be dry of optimum, okay, compaction. If the compaction is done in this part, okay, in this area, then it is called dry of optimum, and if it is done in this area, then it will be called wet of optimum. Okay. You can see the graph here. Okay, this was the compaction curve. The compaction curve, this is this one. Okay, compaction curve. This was zero air void lines. Okay. So you can see this is OMC, as I have just told you. This is OMC and this is MDD. Okay. Now this part, which just I was telling you, this part, which means the water content is less than OMC. OMC is here, and we are concerned about this part, this area. Here we have less water content, and in this area you can see the water content is higher than OMC. Okay. So as the water content is less than OMC, so what we will call dry side, okay, or dry of optimum, and what this will be called? Wet of optimum, or we can say wet side. Now when the compaction is carried out in this area, what will it be called? It will be called obviously the dry of optimum compaction. Okay. This will be called dry of optimum compaction, and in this part what will be called? It will be called wet of optimum compaction, okay, means compaction carried out in this region. We are talking about the compaction which is carried out in this region. Okay. So, this is the general or basic concept. Now, what we will be doing, we will be now discussing one by one the parameters of the soil which will be disturbed or which will get changed due to the different procedures or procedure of the compaction. Okay. Okay. So, let us see what are the main features which gets affected due to compaction. Okay. Effects of compaction on the soil properties. What are the properties which are mainly affected due to compaction? Permeability, compressibility, shear strength, soil structures, swelling of the soil, shrinkage of the soil, pore water pressure and stress strain behavior of the soil. Okay. Now, we will be discussing one by one. Okay. So, we will go into two parts, or we will be dividing this comparison or study into two parts, as I have already told you, the dry of optimum and the wet of optimum. Okay. We will be seeing how will the property be affected if we compact it in the dry of optimum side, and how it will be affected if we will be compacting it in the wet of optimum side. Okay. So, let us see one by one. The first one, permeability. Okay. You know what is permeability? What is permeability? It is the ease, with which, in our case, means generally we will be talking about soil. So, let us talk about water only, because soil generally encounters water only. So, ease with which water is permitted through the voids of the soil. Okay. Through the voids of soil. So, this is what permeability is. Okay. This is the meaning of permeability. Now, let us see how it is getting affected. Compaction reduces the voids present in the soil, hence permeability also reduces. Obviously, you know that what happens before, we can see that the particles are flocculated, it may be flocculated something like this. Okay. Now, when we increase the water content to an extent, or we are talking about compaction. So, if compaction is made or the force is applied, dynamic force, what will happen? The flocculation will break, it will come into somewhat, we can say, arranged way. If it comes into an arranged part, then what will happen? The permeability will obviously decrease. Here it had a large permeability, you can see. Now, the permeability has reduced. Okay. The voids has reduced, because what is compaction? It is the process of omitting the voids from the soil. So, if there is no void, how will be the permeability affected? Obviously, it will get reduced. Now, at a particular density, okay, for the same soil sample, permeability is more for soils which are compacted dry of optimum than those compacted wet of optimum. What does this mean? Same soil, same density. Okay. So, if like this we say, the density is same. Okay. You can say something like this, this is gamma. So, same density, we are talking about same density here. What is it saying? And same soil, obviously it is the same soil or a single soil. Okay. Permeability, if the compaction is done in the dry optimum side and wet of optimum side, if it is done in this part, what will happen? Permeability is more. Okay. And here the permeability is less. Why is it so? Because in this part, if the soil is compact, what will happen? The moisture content is less. So, there are air, okay, air in the voids, more air will be present in the voids. So, since more air is present in the void, so the water will be easily permeable through these voids, okay, pushing the air away. But in case if in the wet of optimum, the water has replaced it, okay, those airs are already replaced by water. So, what will happen? Now, it has to do more effort to push the water and move through the voids. Okay. So, due to the same reason, permeability is more in the soil which are compacted dry of optimum and otherwise less in the wet of optimum. Okay. So, further let us move. Compressibility. What is compressibility? It is the degree, okay, it is the degree to which a soil can be compressed. Okay. It is the degree to which a soil can be compressed. This is called as compressibility. Okay. Now, let us see how it will be affected due to compaction. The compressibility of compacted soil varies according to the amount of pressure applied. Okay. Obviously, if there is a soil, it will be depending upon how much compaction force you are applying to that soil. Okay. If you are applying low pressure range, okay, means you are applying low compaction energy, then what will happen? Compressibility is more for soils which are compacted to wet of optimum than the soil compacted dry of optimum. What does this mean? If there is low, suppose this is the curve, okay. Now, we are talking about this and this side. What will happen? In the compressibility part, you know that when the soil is in dry state, it will be in the flocculated form, okay. And once there is flocculation, it will resist more, okay. It will be resisting the compaction energy more, or we can say that it will not get compacted easily, okay, or it will get compacted in a less manner, we can say. So, due to this, what will happen? The compressibility will be lesser, because it does not get compacted or it does not get compressed. It will try to retain its shape of flocculation, okay. But if we move further, we can say when the moisture content is increased, then what will happen? They will get dispersed, okay. They will get somewhat arranged in this manner. What will happen now? If there are some other particles like this, then now if we apply the compactive effort, this will get arranged, okay. This will get arranged in something like this. So, we can say that the volume, suppose this was like this, now it will get compressed and become like this. So, we can see that the compressibility is more now, okay. So, more in where? In the wet of optimum and less in the dry of optimum. Now, this was for low pressure. Now, in case of high pressure range, what will happen? Compressibility will be more for soils which are compacted dry of optimum than the compacted wet of optimum. Why? You know that in the dry optimum, as I already told you, the soil structure is flocculated, okay. Now, flocculation means in the low range, if the pressure is applied, then they will be resisting the force and they won't be getting compressed, okay. But once you increase the range for the pressure, what will happen? Due to this, the they will get broken, okay. Their bond will get broken due to high pressure and they will get arranged something like this. So, you can say that compressibility will be very high, because you can see there was a huge void here and now it has reduced to a minimal point. So, the compression will be very high in this case. Further, let us move further. We can see now in what will be happening in the wet of optimum. In wet of optimum part, you know that already they get arranged in good manner. Somewhat arrangement is done by the compaction only. So, that much compaction, that much arrangement can be done by the low pressure range as well. So, high pressure range applying to the wet of optimum won't give you high compressibility, because it is already arranged in a most compressible way, okay. So, comparatively if you see, the degree of compression will get reduced in this part and it will be very high in this part, okay. So, this was the concept. Now, let us move to the next. Shear strength. I think you know what is shear strength. I have already spoken about this, okay. Now, let us see how it will be getting affected. Shear strength of the soil compacted dry of optimum is more than those compacted wet of optimum at low strains. Again, at higher strain, what will happen? Compacted wet of optimum will have more shear strength, okay. What does this mean? You know that the shear strength is actually the bond between the soil, okay. The bond between the soil which will be resisting the shear, okay. Means somewhat you can say, if this is the ground, shear, what does it mean? It will means that it will break from here, it will, this will move relatively, this part will move, okay, of the ground, this will move down, this will move up, something like that. So, this will be shear, okay. Now, what is it saying? If we compact on the dry of optimum, then what will be happening? The shear strength of the, it will be more, okay. Dry of optimum means less moisture content. Again remember this one, this is the dry and this is the wet. Okay. So, what will happen here in shear strength part, if we compact in this okay, soil is compacted in the dry, then more shear strength, okay, than the wet. Why? In the low case only. Why is it so? Because as you know, in case of shear strength we have to compact the soil greaterly. Okay. How the more the soil is compacted, the more the bond strength will increase in this part. Okay. So, they will resist the movement like this. So, in case of dry of optimum, we know that there is the flocculation, as I already told you. This flocculation is good in strength, because at low strain it will not break, as I already told you, okay, just before. At low strain this will not break, this will try to retain its shape. At low strain it will try to retain its shape. So, what will happen due to this? Okay, the dry optimum, we can say this will show the more shear strength. Why? This will form like this. If it is a flocculated structure, okay, they are bonded in a greater manner, then if you have compacted in the dry of optimum part, so this will not break, this will remain as it is. So, and this won't let any movement, relative movement, this there won't be any, okay, in this particle, they will remain as a whole, a single body. So, shear strength is more. But if it is a weight of optimum, then what will happen? This will get dispersed, okay, this will get dispersed, and due to which shear strength gets reduced. At higher strength, as I have already, this gets broken, you know that this gets broken to something like this. So, what will happen now? As it is already broken, now there the possibility of shear strength will be more. Okay. So, it is written that the soil compacted to weight of optimum will have more shear strength, because in the dry part what has happened now, it has gone to dispersion. Okay. Besides shear strength, also the shear strength parameter also depends upon the type of compaction, drainage condition, type of soil, means type of compaction. You know that the different soils are compacted in different way. Suppose this is the diagram I have shown you, this is for kneading action, okay, and where this kneading action is used generally for cohesive soil. This is for the cohesive soil. You can see kneading action, these are the projections here, you can see these are the projections on the roller. What will happen? See, these are the, due to this, when the roller rolls from here to here, what happens? You can see there are patterns made on the ground, because this gets inserted into the ground, causing the kneading action. This is generally favorable for clayey soil, okay, or we can say cohesive soil. So, different compaction methods also depend how the shear strength will behave. Okay. Drainage condition, what do you mean by drainage condition? Drainage condition means, suppose there is a ground, if you know, I think what is aquifer, or let it be, just assume that a ground is there, this is the whole soil, okay, this is the ground and this is somewhere rock, you can say, okay, hard strata or impermeable strata, you can say. Now, what will happen? Once you are compacting it, you try to compact it, there will be water, okay, there will be water also, air also in this, okay. So, water will be there and air will be there, air is getting oozed out due to compaction. What about water? If there was the drainage condition, or if the drainage was allowed in this part also, then water would have gone out, some part of the water would have gone out from this part and some would have gone from this part. Now, as this is already restricted because this is rock, okay, this won't let water to go out. What will happen? Only that amount of water which can go out from this face will be able to move out. Okay. So, what will happen? Due to this, the drainage condition will make, or the water inside this will make also, this will also cause a poor pressure. Let me first. Okay. The ground, you remember, this is the ground and this is the soil. Okay, this is soil. So, once water starts getting out, the part which won't be able to get out, this will cause poor water pressure. Okay. So, due to this also the shear strength gets affected. And type of soil, obviously you know, mainly the shear strength part is related with the cohesive soil. Okay, cohesive, sorry, only related with the cohesive soil mainly. Cohesionless soil such as gravel, they won't show or show very less shear strength. Okay, so this was the case. Let's move forward. Soil structure, as you have seen in the figure, this is the flocculated and this is the dispersed one. Okay, so what are we relating with this? Let's see. Soil compacted dry of optimum has flocculated structure due to the attraction between the soil molecules because of low water content. Soil compacted to weight of optimum has dispersed structure due to repulsive force between the soil particles because of high water content. This I have already explained you before as well. On the dry side of optimum, the structure of the soil will be flocculated, okay, something like this, and they have good amount of energy to resist the compactive effort. Okay. So, the structure of the soil after compaction may also remain as flocculated, but in case of dry of optimum, weight of optimum, this was for dry. Okay, dry of optimum. And in case of weight of optimum, what will happen? Some gets already arranged and some may remain like this. Okay, something like this. Once you compact them, okay, this will come like this, as you have seen here also. So, this is weight of optimum. Okay. So, this is the case. Swelling and shrinkage. What is swelling? Okay, shrinkage. Actually, swelling of the soil means when we add water, when we add water, how much volume change it shows. Okay, this is what swelling means. If you remember, we already talked about Montmorillonite and kaolinite. Okay, we talked about the activity of the soil. So, what was happening there? There the swelling was very high due to these two, kaolinite, Montmorillonite and also elite. These three were causing the high swelling of the soil. So, we also termed it as expansive soil. Okay. So, now let us see how is it related here. When the soil is compacted to the dry of optimum, the soil is in need of water and it swells easily, okay, when contacted with water. When the soil is compacted weight of optimum, the soil particles oriented in dispersed manner and swelling does not occur. Okay, to avoid swelling, soil should be compacted weight of optimum. This is an important part. First of all, I think you have already understood what it is saying. In the dry of optimum, there will be lack of water. Okay, water will be less in this part. If you add water, what will happen? It gets swelled. Why? Because it wanted water. It was dry. Okay, so it will get water and it will swell if there are swelling properties of that soil. But in weight of water, the soil has already enough water with it. Okay, if it had to swell, it has already swollen. Okay, now if you add more water, okay, what will happen? No swelling will take place. No swelling. Okay, so this is the thing. Now, shrinkage of soil. What is shrinkage of soil? Just opposite to swelling. What does this mean? Once you remove water, okay, you remove the water from this part or the dry part or wet part. What will be the effect of this removal on the soil structure or soil itself? Okay, we will be seeing this only. Shrinkage is more of the soil compacted weight of optimum than the dry of optimum. Why? Because here it is already lack of water. You know that. If there is lack of water, what does this mean? There will be less water. If that much water is removed, what will happen? Some volume change may occur, but that will be less than the volume change here, because here we have large amount of water. So, the particles are dispersed and all. Okay. So, more water will gets removed once you cause shrinkage here, or you remove the water from this part, wet of optimum. So, due to this, what will happen? More shrinkage will be shown by this part than this part. Okay. The same is written here. In case of dry of optimum compaction, soil particles are in random orientation and they are in stable condition. Stable means they are not dispersed. Okay. They are already in this part and they will remain as this even though water is removed. So, less shrinkage. In case of wet of optimum, soil particles are parallel orientation and they show unstable, which makes it easy for packing of particles causing shrinkage. So, this is talking about the same phenomena. Okay. Pore water pressure and stress strain behavior of the soil. What is pore water pressure? This I think we have already understood. Pore water pressure, as I have already told you, water will be higher in this part and lower in this part. Obviously, do you know that pore water pressure is caused by what? Water. Okay. This is the pressure caused by water on the particles of the soil. Okay. If there is water here, it will cause pressure to it. Okay. It will cause pressure to it. This is the pore water pressure. So, obviously, here we have less water, so pore water will be less pore water pressure, and here we have more water, so pore water pressure will be more. Okay. Pore water pressure is high for those soil with high water content. So, soils compacted wet of optimum compaction will exhibit more pore water pressure than dry of optimum. Okay. This is a simple concept. Now, stress strain behavior of the soil means it is talking about the graph. Okay. Something like this and something like this. Okay. Soils compacted to dry of optimum will take more stress for little strain. Hence, stress strain curve for this type of soil much steeper and elastic modulus is more. Brittle failure occurs. This is the curve. Okay. We can see in the next diagram. Here it is. This is for dry compacted soil and this is for wet compacted. Wet compacted and dry. What is the difference? Here what will happen, as there is flocculated structure, as I have already told you. Okay. So, what will happen? It can take very high stress without much of strain, or you know what is strain? Strain is the change in the dimension, you can say, or length, delta L upon L, generally it is referred as strain. Okay. This is strain. So, without much change in this structure, high stress can be beared by these type of structures. Why? Because they are flocculated and already bonded together in a good manner or good strength. Okay. So, up to a part you can see they will be, you can see up to a part the stress is increasing very rapidly, but strain is not comparatively. You can see it is very high and it is low. Why? No dimensional change is getting place, because it can bear that much of a stress. But after that what happens? This bond breaks. Okay. So, brittle failure and you can see sudden decrease in the stress comes out. Why? Because now this bond breaks out, due to which the graph gets reduced. In case of wet compact, what will happen? Gradual increase. You can see there is a gradual increase in the graph. What does this mean? Corresponding to the applied strain or stress, the strain will increase. Okay. The strain will increase because now there is no such structure to resist. As you increase the stress, so will the strain increase. So, this will give gradual increase. Okay. You can see similarly, soil compacted to wet of optimum will produce more stress even for smaller stress. Hence, stress strain curve in this stage is flatter. Plastic type failure will occur. Okay. What is plastic type? Means gradually. Okay. This is called brittle failure and this is the plastic failure. In plastic failure, not a definite point of failure can be obtained in plastic failure. Okay. You can see there is no definite point, you cannot understand where the failure has occurred. In this you can say that here the failure has occurred. This is the brittle failure, this is the plastic failure. Now, let us go to a numerical problem. It is about the optimum moisture content. Let us see what is given to us. The optimum moisture content of a soil is this, maximum dry density is this, the specific gravity of the soil solid is this, determine. First, degree of saturation and percentage air content at OMC means this one. Okay. Second, theoretical dry density at OMC corresponding to 0 air void. This is a different case. First, let us see this one. This is a easy question. You know, what are we given with? OMC is given, maximum dry density is given, and G is given. We can use again the formula W into S. Formula is S into E is equals to W into GS, or simply you can say G. Okay, this is the formula. Okay, we need degree of saturation, so we can find out it from here, but we don't know E as well. So first of all, we have to find E. What we will use? We will use the gamma D formula. What is gamma D? G gamma W upon 1 plus E. This you already know. Okay, G is given to us, E we have to find out, gamma W you know, it's always a constant. For gram per cc if you are using, then it will be 1, else it will be 9.81. Okay, so let's see. You can see here the same is done, the same formula is being used. You have, it is in gram per cc, this is in gram per cc, so 1 is used, which is also in gram per cc. So here you have found out E. Again the same formula is used to get S. Okay, the easy question. Now let's move to the second part. Okay, we also had to find the percentage air content. If we have the degree of saturation is this, then obviously if you remember, S plus air content was 1. So from here you can find out air content percentage. Okay. Now the next case in which it was told that 0 air void. Okay, 0 air content we have to find. For corresponding to this, we have to find the gamma. Okay, so what we will do? S is 1, again use the same formula. So you will get a new E. Now you can see a new E is obtained. Corresponding to this, again the same formula is used to get a new gamma D. Okay, this is the new one. In this case, what was different? S was 1. In this case, S was 63.5. Now it is 100%. Okay, fully saturated. At, you know that at the 0 air void line, which was like this, the 0 air void line, okay, 0 ZAV we can say, or 100% saturation are same. Okay, so we have done that, is fully saturated, so S will be 1. From here we have calculated further. Okay. So this was it for now. We will now just go through the questions, answer them, try to brush up your concepts again. Next time we will be again talking about the compaction of sands. Okay, different methods how we compact them. So keep watching the videos, remain joined with us. Thank you.